Assalamu alaikum everyone, hope you all are doing well. So today we will discuss our new topic, that the discovery of proton, or you can say the proving of proton. Day before yesterday we have discussed about that discovery of electron. As same we will same there's a same process, but there's just different changes in the proving of proton. So first of all, the name of scientist that proved about proton is Gold Goldstein. Goldstein proved about the proton. Proton. After that, which apparatus has been used in that one? Like we have used discharge tube. So in this one, same we are using discharge tube. Goldstein and discharge tube. After that, first there's not any kind of a specific definition. We'll just discuss about this one diagram, that how this diagram possesses. So let's move on. That okay, we are having in discovery of electron, we are having a high voltage generator. Here is high voltage generator. What this high voltage generator does do, that when it moves over, this is a high voltage generator. After that, when it moves pressure from here over there, so here we are having perforated cathode. What the name of cathode is? Perforated cathode. Why we give the name it's a perforated cathode? Because means like a holes in a cathode from where protons pass and comes at the behind of the cathode. So that's why we have taken perforated cathode. It very low temperature, what happens that this pressure moves over inside this one, and here are the gases. Here are the little gases. Like first of all, we should take, I am taking the H, hydrogen gas. What happened, like here's a hydrogen gas and we ionized that gas. Like here I am having H and I ionize that one gas, and what will happen, that it will produce electron and proton, two different things. Like in hydrogen, we know that in hydrogen we are having one proton and one electron. One cathode rays come over here and move to this one. So what happens, uh, there is a sign of one proton of positive and plus one electron of negative will remain. And what happens, the same thing over here, that electron as a negative and proton as a positive, this when it's ionized, so these both things come over there, over here inside this one discharge tube. And these electrons, as I told you day before yesterday, that these electrons have negative charge, so it move to the behind of the anode rays and glow up over there. And these protons move over these perforated cathodes. It move from these holes and glow, as you can see. Just wait. Just showing simple diagram, that as you can see over here, that this is glowing over here. Here's a red light over here. It means that those protons, we were having electrons and protons over there, these protons perforated from these cathode rays and then glow up over here. This all process is called the discovery of proton, or you can say that the proving of proton, that how proton produce, because electron have negative charge, so it repels from the negative charge and move to the positive side, and proton has the positive charge, so it repels from the anode positive and move to the negative side. So this is a process that how a proton formed. Now one more thing, that I am having two key points over here to tell you. We are having two key points. Number one key point is that which gas has more mass, which gas has more mass, so it have less em. As you know that the meaning of em means charge and mass. Okay, and second thing is opposite of this one, that which gas have less mass, so it have more em. Okay, now let's move further. Let's discuss about electric field properties of proton, proving of proton. Like we have discussed the properties of cathode rays over there, so we will also run over here the, oh sorry, one more thing I just forgot to tell you, that likewise, just wait, what this process called, like when a light glow up over here, this process is called the cathode rays. But when light glow over here in this one side behind of the cathode, so this is called the positive ray, or you can also say canal rays. I am writing over here positive or canal ray. Now, as we have discussed last about the properties of cathode rays, now we will discuss about the properties of canal rays. Properties. Number first property is electric field. Like electric field means we are having charge in electric field. So we will discuss about charge in it. And second thing, we are having magnetic field. That's also another property of the canal rays. Magnetic, as I told you that it's same like as cathode rays, so there's the same properties, mass, these two things. After that we will also discuss about casting shadow, that how casting shadow formed, shadow. And then we will talk about lastly about zinc sulfate, zinc sulfate, ZnS, zinc sulfate. Zinc sulfate. Now first of all, talking about electric field, in electric field we are having charge, but how? Like previously, cathode rays have a negative charge, so what it do, that the negative charge move to the positive side. Like we lastly we were having this line, cathode rays, and here we are having you can say the electric field, positive and negative sign. So cathode rays have a negative side, so it moves to the upside in a electric field charges. Okay, but in a positive charge, or you can say in a canal rays, there it doesn't happen. What happens over here, this is a positive charge, you can say the positive ray, positive R. This is a positive ray, and what happens that here we are having magnetic field. This is a positive, this is a negative. As positive ray have a positive ray have a positive sign and positive charge, so it moves to the negative side. Where it moves to the negative side. So this is the process of electric field. It means electric field have a charge, but in magnetic field, what happens that we are having same over here like in previous one, that we are having magnetic field, we are having this is a magnetic field mass, we are finding mass, we are having positive ray, or you can say canal ray. What it do, that here we are having south and here we are having north. What it does, that it's moved from over here and done, wait just, yeah, it moves over here and just came downside. Now there's a one question, that in cathode rays we are doing same, like we are also doing the same thing. How we know that is the mass of cathode rays or the positive ray? So one thing, notice one thing just, that in cathode rays what happens, that the cathode rays come over here and it moves, it not sharply move bend down, it moves forward and then it bend down. But in this one, what happens, that it's move sharply through down after the magnetic field bend down. So this process is called the we have find a mass. It move down sharply downward, it means it's having mass. After that, talking about casting shadow, what happens in casting shadow, that this is a, we are having positive ray, and here we are having you can say one mirror or one object. What it does, that when it moves over here, when it moves over here fastly, so it just move on and making a shadow straight, very straight. Like here we are having positive ray, it moves over here on the wall and it's make a shadow somewhere, because it's having positive charge, so it's have a straight line, so it's make a shadow. Okay, now move further to zinc sulfate. Okay, in zinc sulfate what happens, uh, here we are having a line and here we are having zinc sulfate. Okay, zinc sulfate, what happens, that when positive ray, right here P R, when positive ray come over here to the zinc sulfate and zinc sulfate glow brightly, means it will glow more, because of positive ray have a heavy mass, so heavy mass have more glow than the less mass. After that, if we are taking the cathode ray over here, but cathode ray also strike this one and having less less glow up, because the cathode ray have a less mass, because cathode ray have a less mass, because of that it's not glow that much. So this is the difference between the positive ray and the cathode rays, that in a zinc sulfate how it's work. And there's a not a big huge difference, but there's a just little difference over there, because here is a proton and it's move over down to the uh, behind of the cathode rays and name as the canal ray or positive ray. So in today's lecture we discuss about the proving of proton, name of scientist, apparatus and their diagram, and the little bit the changes difference between proving of electron with the cathode rays and the proving of proton. Hope you all understood. Thank you so much.